Hello everyone, this is Saji again. Today we're going to look into rigid motion, or you can call rigid transformation. Same thing. Today we will look into rigid transformation so we can move figures in a plane without changing shape or size. You know you have it when we need to translate figures without changing shape or size. Here are some vocabularies: translation, rotation, reflection, move, slide, spin, flip, pre-image, image, origin, and prime. What is rigid transformation? Rigid transformations are moving a figure without changing shape and size of a figure. For example, over here, we have a triangle. We move this triangle all the way here. We didn't change the shape or size. It's exactly the same size and shape. If you move this triangle and at the end, if you get square, it's not a rigid motion. Or if you get smaller triangle, that also not a rigid motion because the size changed. Same thing over here. If you imagine this is a mirror, you are figure over here, and then your figure image, it's going to be like this. And exactly the same size and shape. If you have a door and it swings, if you have a little tag on your door and when the door swings, it moves, but the tag doesn't change the shape or size. What are the three types of rigid transformation? Translation, rotation, reflection. These are the three types of rigid transformation or rigid motions. What is translation? Moving a figure from one place to another without changing shape and size. Here's the example. You have a triangle over here. You moved all the way here. The size or shape doesn't change. Let's look at some example and see if we can find the answers for these things. There's a point is at 2,7. That's where it's located in a grid paper, and it's translate 3 unit right and then 2 unit up. Can we move that? And how we do it? We just look at it. So let's look over here. You have a point which is called X, and we have to move X 3 unit right and 2 unit up. So what are we going to do? We're just going to move this first 3 unit right and then 2 unit up. So at the end, it's going to end up over here. This is called X prime. This one is 2,7. And this one is going to be 5, 9. See how we get this? I mean, they gave you the coordinate, which is 2,7. So I just drew a vertical line on through the X is equal to 2, and then horizontal line through X is equal to 7. Where it's meeting, that's where the point is. In here, it's 9 and 5. I mean, like a 9 is the Y value, 5 is the X value. So 5 is the X value and 9 is the Y value. Okay. So this is how you move the point. So we basically move the point from here to here. Instead of we count the grids and all those stuff, we can do by calculating 2. So the original point, X is equal to 2,7 X, okay? Now they are saying 3 unit right. If you move right, you're gonna add to the X value, 3 unit. If you move up, which is Y, which is 2 unit, you're gonna add. you're going to end up with 5, 9. So when you move right, you add it. What happens if you move left? You're going to subtract it. When you move up, you add the value to the y. But if you move down, what you're going to do? You're going to subtract the value to the y. So when you move right, add the value to the x. When you move left, subtract the value from the x. When you move up, add the value to the y. When you move down, subtract from the value to the, from the y value. All right. Let's say if we move 2 units down, left, and 3 units down. How are we going to do it? So we have x over here. Let's we do it with counting, or just going going by each unit, and then we calculate it and see if those came the same or both of them are going to be the equal. So 2 units left. So I'm just going to go 1, 2, and 3 units down. 1, 2, 3. So we're going to end up over here, x prime. Okay. Do the same thing. 2, 7. 2 units left. So we're just going to subtract 2 and 3 down, minus 3. These are the y value, x, y. So 2 units left. So from the subtract from the x, so minus. So it's going to be end up 0. And y value is going to be 4. Let's see if it's the same thing. See, this is 0, x value, and the 4 over here. So this thing is 0, 4. So both way can be right, but I highly recommend you learn this way. All right. So now you look at it, move a line segment, or move line segment PQ 3 units right and 2 units down. Let's see if we can do that. So we have to move 3 units right, 3 units right, and 2 units down. And we have a point, PQ. I'm just gonna mark over here, here. This is a PQ line. So if you look at it, this is the PQ line. We need to move 3 units right. So we have to move this line 3 units right. So we know how to move the point, but we have to take everything. Now it's like entire line. It sounds a little tough, but it's pretty easy. Basically, this is a line segment. So I'm going to take these 2 endpoints and move it according to what they're saying. So I'm going to move P 3 units right. So I'm going to move P 1, 2, 3. It's right over here. And then 2 units down, 1, 2. So P is end up over here, become P prime. Same thing with Q. We're going to do the same thing. 3 units right, 1, 2, 3, and 2 units down. So it's going to end up over here. So now we just move it. The line comes all the way here, which is Q prime. You can do the same thing with calculating. So you know the P is 2, 5, 2, 5. So I'm just going to say P is 2, 5. Oops. 2, 5. Now you're going to move 3 units right. So if you move 3 units right, you're going to add to the x value and 2 unit down. So that's the y value. When it's go down, you have to subtract it. So it's going to be end up like 5 comma 2. So if you look at it, 5 comma, oh, 2 unit down. So it's 2 unit over here. So it's going to be 5 comma 3. So it's going to be 5 comma 3. See, 5 comma 3. All right. How about Q? Same thing. Q we have over here 4 comma 3. So this is P prime. 4 comma 3 over here. Now 3 units right. So we're just going to add 3 and 2 units down. We're just going to subtract 2 on the y value. So when we do it, it's going to be 7 comma 1. See, 7 comma 1. And then you connect it. So basically, when you move a figure, we're just going to take all the points, endpoints or vertex, and move those points, and then we connect the dots. All right. If you have any questions on that, please ask me in the office hours. What is reflection? Reflection is flipping a figure across a fixed line without changing shape or size. All right, if you look at it, if you have a line, if you flip it according to this line, it's without changing any shape or size. That's called reflection. So basically it's a mirror. You have an object, and when you look at it, it's going to be over here. So if you have a point, like for example, you have an x at 2 comma 7, reflect, x is equal to 0. That is the line, which is when x is equal to 0 or x is equal to just a number, that's the vertical line. Go through whatever the number equal to. All right. So let's see if we can do that. So this is the point we have to reflect at x is equal to 0. Where is x is equal to 0? It's right over here. And then the vertical line go through x is equal to 0. It's right over here. So this is the line. So let's say now we have a mirror like this. All right. So if we have it, where is it going to be like the image going to be? I just put a little big size of point, but you can put a small one. It's going to be 2 comma 7. So it's going to be how many units away from this mirror? 1, 2. The same thing, we have to go backward. 1, 2. It's right over here. And how many up? It's going to be the up is the same thing, which is 1, 2, 3, 4, 5, 6, 7. Same thing over here. So we are already here. And 1, 2, 3, 4, 5, 6, 7. So the image is going to be over here, x prime, which is negative 2 comma 7. All right. When you reflect on x-axis, the x value changes the sign. When you reflect on y-axis, which is x is equal to 0, the x value changes the sign. See, if you look at it in here, this is 2, this has become negative 2, and rest of it same, does stay the same. If you do it in y value, just an example, if you do reflect at y is equal to 0, which is this one, because y value is 0, so this is the mirror. All right. What's going to happen? This, how many units away from the x-axis? 1, 2, 3, 4, 5, 6, 7. We're going to go backward. 1, 2, 3, 4, 5, 6, 7. It's right over here. And 2 unit, 2 unit. This also X prime, or you can put double prime if you want it. It's right over here, sorry. See, I count the unit 1, 2, 3, 4, 5, 6, 7. You're going to count 1, 2, 3, 4, 5, 6, 7. And this one going to be negative, 2 comma negative 7. So what did you notice from our original image, which is a pre-image and an image? When you reflect on x-axis, the y value changed the sign. Did you see that? This is positive x, negative x. When you reflect on y-axis, the x value changes. All right? There's some other way that we can do it too. For example, if you say reflect on x is equal to 2, the same thing. No, sorry, x is equal to 1. If it's x is equal to 2, it's going to be exactly the same thing. So what's going to happen? I'm going to draw the mirror. Where do I need to draw the mirror? So now we have to reflect at x is equal to 1. Where's x is equal to 1? It's right over here. All right. So what do you need to do? Count that. How many units from this mirror? 1. So it's going to be over here. So you're going to go away from that mirror. It's 1 unit. All right. This is the mirror. You go away. So it's 1 unit. You just jump to get the mirror. And if you want to get the reflection, you have to jump 1 unit away from the mirror. So that's where it is. Okay. So this one is going to be 0, 7. All right. If you have any questions, please feel free to come to office hours. So now you have a line. You have to reflect over x is equal to 0, which is y-axis. So how does it going to look? You're going to take each point and do the reflection. So I'm going to take the P point. How far away from the reflection line? Because x is equal to 0, which is a y-axis. So I'm just putting this as a mirror. So 1, 2. To get to the mirror, you jump 2 places. So to get the image, you have to jump 2 away in the same direction. Okay. Same thing over here. 1, 2, 3. You have to jump away 3 on this side, opposite side. If you connect that, that should be your image. So this is going to be P prime, Q prime. Okay. That's how you do it. All right, what is rotation? Rotation is turn or spin the figure around a fixed point without changing shape or size. For example, I can give you, if you put it on top corner of a door something, a little notice or something, and then you swing it, that note shape or notice shape or size doesn't change, but it moves it. That's what it's called rotation, because the hinge is the rotation line. You know, all those 3 hinges on the other side of the door, those are the hinge, which is a line, and you are moving that notice around that fixed line. In here, so you have a door over here, and you are hanging a little triangle piece, and when you swing it all the way here, it still doesn't change the shape or size. All right. So that's what we're going to look at it, and we're going to talk about 90 degrees, 180 degrees counterclockwise. Same thing on Clockwise, you can do 90 degrees, 180 degrees, and 270. All right, let's see. So you have a point at 4,3, you have to rotate 90 degrees from the origin, counterclockwise. So you have a point at 4,3, and you have to rotate 90 degrees counterclockwise. Okay, let's see if we can do it. You have a point over here, just put point P if you want. And you're going to rotate from the origin, which is O, 90 degrees counterclockwise. Clockwise, it goes left to right and comes circle around. Everyone knows that, how the clock runs. Counterclock backward against the right to left. Okay? So now we have to move this point 90 degrees counterclockwise. How can we do it? One thing we can do, we can just draw a nice straight line and put the protractor and measure the 90 degrees and put that. On the other hand, we can do, just calculate it. I will give you a little trick. 4,3, so this is 4,3. You're going to rotate 90 degrees. How can we do it? You just switch these two numbers. So when you switch it, it's going to be 3,4. Now you look at the x value and change that sign. This one, I mean, like in here, x value positive, in here, x value negative. Just change the x value after you switch it. So let's say it's going to be 3, -4. It's right over here. I mean, -3, 4, -3, 4. If you draw it from the origin, if you draw a line, this one should be 90 degrees. So if you do one more 90 degrees from here to here, what do we have to do? We're going to take this number, which is -3, 4. We're going to switch this number, which is 4, -3. And then we have to change the sign of x, which is -4, -3. -4, -3. So it's right over here. If you look at it, that's a straight line. So if you see it, now you can find the relationship between the origin, I mean the original image or the pre-image to the image. When you do 980 degrees, because 90 degrees plus 90 degrees, 180 degrees, you're gonna have the same number, but the sign changes. All right. Now, if you rotate it from 180 to 270, what do we need to do? We're going to take this number, -4, -3. When you rotate 90 degrees, what we have to do? We have to switch the number, -4, I mean 3, -3, 4, -3, -4, and then change the sign of x. So it's going to be +3, -4. So it's going to be +3, -4. It's right over here. When you connect it, this one should be a straight line. Let's see, because from here to here, it's 180 degrees. So just see it if it's work. Yeah. You just switched it. This one going to be 3, -4. So you could easily rotate anything. So now I'm just going to say you have a line. So we already rotate one point. I'm just going to make it easy, make the life is easy. This one is going to be the end point. I have a line segment over here, which is 3, 5, 3, 5. When you rotate this line, I mean this point, PQ, I'm just going to put P. This is P prime. When you do 1 point rotate too many times, we just put at the prime for H1. And this one going to be prime 3. I mean P3. So it's going to be 3 apostrophes you're going to put on the top. Now we have a Q. Where's this Q going to go? We have a point which is 3, 4. What do we need to do? We have to switch it. The first step, 4, 3, and change the sign. So it's going to be negative 4, 3. So where's negative 4, 3? It's right over here. Is it 3, sorry, this is 3, 5. So this is 3, 5. So it's going to be negative 5, 3. All right. So negative 5, 3. It's right over here. That point. So the Q prime, it's right over here. So if you connect it, when you do 90 degrees, this is how it's going to look. All right. Now you have the point Q prime, which is negative 5, 3. All right. What's going to happen to the Q prime 2, the Q1, Q2? We have to switch this, keep the number and put the negative. In here, we have to keep the number and put the negative. So it's going to be negative 3, negative 5. So it's going to be negative 3, negative 5. It's right over here, negative 3, negative 5. That's what we learn. When you rotate 180 degrees, you keep the same number and switch the signs for both numbers. So that's how it's going to look. All right. So this is Q prime prime or double prime or 2 apostrophe. Okay. When you rotate the third one, we just need to switch it and change the Y value. See, change the sign of Y value. See, we just switch it and change the Y value into negative or change the sign. So what are we going to do in here? 3, 5. So it's going to be 5, 3. 5, 3 and change the value, which is going to be 5, 3 and change the Y value, negative 3. So it's going to end up over here. See, we don't need to measure or anything. We just can do with the math. This is how we learn. This is what we learn in geometry. It's beautiful. Am I right? So now you know how to translate or move a figure or line or point, how to rotate it, and how to reflect it. All right, guys. Again, have any question? So we came to an end. If you have any questions or concern, feel free to come to my office hours. All right. Thank you, guys.